Okay, let's get started here on the 1.4 homework. This one's probably going to take some time. So I'll probably be using some of the solutions that they have here to kind of move through this a little quicker. Given that you have a function, given that you have a limit of a function f, where when you approach 2, it's 9, another function g that when you approach 2, it's -5, and a limit of another function h that when you approach 2 is 0, it asks you to find these results. So this is just using some of the properties of limits. So let's take a look at this first one here, a. What's happening here is you have a sum of two limits, which means you can break this into two separate limits. So I do two separate limits like this. All right, and then from there, I have a constant sitting out in front. Try this. Constant sitting out in front, so that constant can come out. That's another property of limits. So what I get now is limit x approaches 2 f of x plus 5 times the limit as x approaches 2 of g of x. Now the limit as x approaches 2 of f of x is 9 plus 5 times, now the limit as x approaches 2 of g is -5, so times -5. So we get 9 minus 25, which is -16. So it's just a matter of applying these rules to our expression and then breaking it up and then plugging numbers in. All right, let's try the next one. Okay, next one here. Come on, you can do it. This one here, we use the property that having this cubed out here means what we can do is take the limit as x approaches 2 of g of x. Instead of cubing g of x here, we can move the cube outside the limit and do the limit first. Now the limit as x approaches 2 of g is -5, so that's just -5 raised to the third power, which is -125. Okay, this one here, what we can do is we can take the limit and push it inside the square root. In other words, do the square root after you do the limit. And the limit of the function f as we approach 2 is 9, so we get square root of 9, which of course is 3. This one, we can do the limit on top and the bottom because it's a fraction, and I'll pull that 5 out on top. So 5 limit fx as x approaches 2, and then on the bottom, it's just a g down there, so limit x approaches 2 of g. Whoa. And then that's 5 times, let's see, what was that f limit? It was 9 over the g limit was -5. This turns out to be -9. So you kind of get the point of how this is working. I think that's probably sufficient. Let me see if there's anything else here. This one, all you do is multiply, do the limit here, do the limit here, do the limit here, and then multiply those two answers and divide by that other one. So I'll just leave that. Okay, the graphs of f and g are given. Use them to evaluate each limit. So here's f, here's g. All right, we'll probably do, let's see, do I want to do all these? Try and do a few. All right, so how about this one? This one turns out to be, because it's a sum, you can split it into two limits. Do the limit of f, add to that the limit x approaching 2 of g. And now let's go ahead and work on this one first. So I go over here to my graph. Let's see the origin. That's one. Here's my origin right there. As I approach 2, 1, 2, I have my imaginary line. My function is approaching from both sides. It is approaching the value of 2. So this is 2 plus, now I go to my g function. See, my origin is here. And I'm limit as I approach 2, so 1, 2. Actually, as we come in from the left and the right, they're approaching a value of 0. So your answer here is 2. That's how you do each of these, except, like on the next one, we're approaching 1 instead. So let me just show you what would happen if you approached 1. Get rid of this stuff. I'll do 1 on each of these. How about we go with a different color? Okay, so if I'm approaching 1 instead, so I go out to the right one, and now as I come in like this and this, from both sides, the limit exists, and it's 1, so this would be 1. Then plus, now over here, I'm approaching 1. From the left, I'm up here, it looks like 2, but from the right, it's approaching 1, so that limit doesn't exist. So this limit right here does not exist. Therefore, this whole thing does not exist. All right, so I think you can kind of hopefully get the gist of this. You just have to look at where you're approaching, and then either, like in this case, split it up, multiply the 2 answers, divide the 2 answers. Here, this one's kind of interesting. If x is approaching 2, and you have x cubed and you have f of x, then what we would do here, what we would do here, as soon as I get my drawing tool back, is we would do limit x approaches 2 of x cubed times, because there's multiplication between them, limit x approaches 2 f of x. So here, we're not looking at the function in the graph up there. We're just letting x go to 2. So 2 cubed is 8. So this is 8 times. Over here, we need to go look at our graph. What's the function doing what's f doing as we approach 2? So up here at f, let's see, we approach 2, it was approaching 2 also. So that's going to be 2 there. And so you should get 16. Okay. Next one. Evaluate the limit using the appropriate limit laws. So again, on this one, I'm going to just use the solution here. So you have the limit of a fraction, or a ratio. So you can apply the limit to the top and bottom separately, which is done here. And now, because you have subtraction, you can apply the limit to each one individually. And then on the bottom, you have 3 terms separated by addition, subtraction, all right? So you do the limit on each one of those. And then since this one has a 2, we pull the 2 out. This one has a -3, we pull -3 out. And then this one is just 9. So now you just look at all these. Look at this top left. Let t go to 2. Okay, that becomes a 2. 2 to the 4th power is 16. Let t go to 2 of 3. Well, there is no t in here, so your answer is just that number, 3. Here we have limit t goes to 2 of t squared. So 2 squared is 4, but then we had a 2 out front. 2 times 4. Now over here we have a -3 out front. Here we've got 2 there. And then here, 9 doesn't have a t on it, so it's just going to stay 9. Work that all out, you get 13 over 11. Okay, evaluate this limit or state if it doesn't exist. So on this one, let's look at the solution. Okay, here we are going to, first let's try and plug in and see what happens. Okay, if we do the limit on the top, we get 5 squared is 25 minus 5 times 5 is 25. So we get 0 on top. On the bottom, we get 5 squared is 25 minus 4 times 5 is 20, and then minus 5. We get 0 on the bottom, so we get 0 over 0. That's undefined. Now, this is why we do calculus. We have to try and figure out what happens when we get 0 over 0 like this. So we factor the numerator. That means we factor out an x. The denominator is a trinomial. We factor it. We notice these 2 factors cancel. So we're left with x over x plus 1. And now when we let x go to 5, the top turns into 5, the bottom turns into 5 plus 1, so we get 5 over 6. So what we're saying, remember, is that if you plug 5 into this, you get something undefined. But if you let x get closer and closer and closer and closer to 5 without actually getting there, then the answer gets closer and closer and closer to 5/6. So in the limit, this ratio is getting closer to 5/6. Close. Okay, next one. How about this one? Where did it go? Okay, so what about this one? If you let, there it is. If you let x go to -1 up here, you get -1 squared is 1 minus 6 times -1. That's same as plus, so you get 7 on top. If you let x go to -1 here, you get -1 squared, which is +1, minus 5 times -1, that's +5, and then minus 6, so you get 0. This time we get 7 over 0. Not 0 over 0, but 7 over 0. And whenever this happens, at least at this point in this class, we're just going to say that this limit does not exist. And that's only because what we have is a number, a fixed number on top, that's not 0, divided by something that's headed towards 0. So in that case, we say it does not exist. All right. Okay, how about this one? Let's just look at it real quick here. If we let t become -5, -5 squared is 25, so 25 minus 25 is 0. So we know we have a 0 on top. See, -5 squared here is 25 times 2 is 50. So we have 50 here. 11 times -5 is -55. So we have 50 take away 55 is going to be -5, then plus 5 is going to give us 0. So this time we do have 0 over 0. So what we'll do, and I won't bring up the solution, is I will do some algebra because we have 0 over 0. Okay, that's the form we have. We have a form of 0 over 0. Whenever we have a form of 0 over 0, you always want to try and do some algebra to try and make things work out, get things to cancel. So I'm going to notice that the numerator is a difference of squares. And my denominator should factor out here 2t, let's see, t, we need a 5 here, 1 here. Let's see, we want this to be 11, so 5. What am I missing here? Can't do a simple factoring problem right now. My brain's farting. Okay, let's just check it. 2t squared, 10t, 11t, 5. Okay, so there's my factoring. Now notice that these two cancel, and that leaves us just limit t goes to -5 of t minus 5 over 2t plus 1. Plugging in now -5, so taking the limit, we get -5 minus 5, it's -10. And then we have, what's going to happen here? Oh, good. Then we have 2 times -5, it's -10, and then plus 1, so we get -9, so we get 10/9. So that limit did exist. We actually got a number here. Okay, how about this one? All right, for this one, let h go to 0. So if h becomes 0, we get -5 squared. -5 squared is 25. 25 minus 25 gives us 0. And then, of course, on the bottom, if h is going to 0, that's going to be 0. So we get 0 over 0. So we have the form that we know we need to do some algebra on. So I'm going to walk you through the algebra here. First thing we're going to do is we're going to expand this. We're going to multiply that times itself. That means you have to FOIL it. And when you do that, you get these 3 terms. Then you have the minus 25. This 25 and this minus 25 cancel. That leaves you the -10h plus h squared all over the h. The top 2 terms have an h in them. Factor an h out. Cancel the h's. Once the h's cancel, you're left with -10 plus h. At this point, you let h now go to 0. This h vanishes, right? It's not going to be there anymore. It's going to become a 0. And all you're left with is the -10 out front. See if this one works the same way. H goes to 0. H here goes to 0. You get 7 cubed. 7 cubed is 343. 343 minus 343 is 0. On the bottom, it's also going to 0. So what we're going to have to do is multiply that out, and I'm not going to go through that, so I'll just bring up the answer here. So you're going to have to take this right here, 7 plus h, and multiply it times itself. 7 plus h times 7 plus h times 7 plus h. Multiply that all out, or expand it, and then collect all your like terms. You should get these 4 terms. Once you've done that, you notice that 343 in the front cancels with 343 in the back. leaving you these three terms. They all have an h in them. Factor an h out, cancel it. You'll be left with these three things. Once you're there, let h go to 0, so this term vanishes, and all you're left with is 147. Okay, let's take a look at what's happening here. Here we have x is approaching -2. -2 squared is 4. Plus, let's see, 4 times -2, that's -8. So we had 4 minus 8, that's -4. Plus 4, that's 0. -2 squared, -2 to the 4th power is 16. 16 minus 16 is 0. So we're going to have to do some work here. I think I'll do this one. So we have limit x approaches -2. So I need to do some algebra, right? Because I've got 0 over 0. That's the form I've got. The top, x plus 2 times x plus 2. You could write x plus 2 squared, but I'm just going to leave it. So I factored that. The bottom is actually x squared plus 4x squared minus 4, because it is a difference of squares also. This is x squared squared minus 4 squared. So I'm using a difference of squares formula on that, but I have to realize x to the 4th is x squared squared. And then now, this right here, x squared minus 4 becomes x plus 2, x minus 2, right? And now what you'll see is one of these factors cancels right there and right there. So what you're left with is the limit as x approaches -2. Let's see, x plus 2 on top. On the bottom, you have x squared plus 4 was still there, and then we still had an x minus 2 there. Now let x become -2. -2 plus 2 is 0. Uh-oh, this looks bad. -2 squared is 4, plus 4 is 8. So we have 8 times. -2 minus 2 is -4. So we don't get a 0 on the bottom, but we get a 0 on the top. So the answer is 0. I wonder if they, in their solution, I wonder if they talk anything about the difference of squares. No, they don't really do anything there. They just do exactly what I did. I mean, they don't explain it, I guess. All right, next one. All right, this one's going to be a monster. Okay, let's let h go to 0 in this expression. If h goes to 0, you get square root of 49. Square root of 49 is 7. 7 minus 7 is 0. All over, h is going to 0, so that's 0. So we do have the form 0 over 0. So we have to do some algebra. Question is, what do you do? Because there's no, nothing to factor. So whenever we see square roots, we always want to start thinking conjugate. So what I'm going to do is take the original limit right here. I'm going to introduce the conjugate on the top and bottom. So there's the conjugate of the top, right? It's the same exact thing, but with a plus sign here. And then when I multiply FOIL out, I go here times here, right? Maybe I'll bring in some parentheses so you can see this. We're doing like this, and then we're going to go this term times that one, this term times that one, this one times that one, and then this one times that one. And what we know about conjugate is that the middle two are going to cancel. So the only ones we're really concerned about are the first ones, right? Oh, wrong one. These two, right? Those two, and then the last two are the only ones that are going to matter. So when you take square root times itself, that means you're going to square our square root. And then when we take -7 times +7, you get -7 squared. On the bottom, all we did was put this in parentheses and threw an h out in front of it. So that's this. Now on the top, when you square a square root, it goes away. So you get 49 plus h. And then, of course, 7 squared is 49. These 49s are going to cancel right here. And all you're going to be left with is an h on top. Well, that h on top is going to cancel with that h on the bottom. And then, of course, you have a 1 on top. And then you have this thing that was in parentheses here. You've got that sitting right here. Now let h go to 0. This is h is going to go to 0. You get square root of 49. That's 7, but we had plus 7. 7 plus 7 is 14. 1 over 14. Pretty nice. Okay, number 11. Ooh, this is a nice one too. Let's let x go to 4 here, see what happens. 2 minus, let's see, square root of 4 is 2. So 2 minus 2 is 0. 4 times 4 is 16 minus 16. So 0, 0. We've got the form we want. I see square root, so I'm thinking conjugate already. But I'll let the answer walk us through this a little faster. So here is what I'm going to get the conjugate of right there. So the conjugate of that is itself with a plus sign, right? Top and bottom, introduce it. Then do your, remember the first ones and the last ones are all that are going to matter. So 2 and 2 is 4. And then root times root, the root goes away. It's a negative times a positive, which gives you negative. So you get negative x there. The bottom, notice that I'm not going to multiply these together. I'm just going to leave them side by side. And also in this one, you can factor an x out. Okay, that's important that x came out. The reason why that's important is because this and this are identical now, and they will cancel. So all you're left with is a 1 up top, and then you got that x down there, then you got that 2 plus root x, and now you let x go to 4, and this thing is going to turn into square root of 4, which is 2. 2 plus 2 is 4, right? And then times 4, so you get 16, and then on top you had your 1. All right, here we go. This is a nice one. Let x go to negative 8. 1 over negative 8 is negative 1/8. 1/8 minus an eighth is 0. 8 plus negative 8 is 0, so you get 0, 0. So here we have a fraction, right? Fractions up top all over something, so this is a complex fraction. Whenever you have complex fractions, we want to get common denominator between the top two fractions. Shall we look at theirs? Yeah, let's do that. See how good it is. And they don't really show that step, but I'll kind of assist here. What they did is they said, okay, I need the same denominator between here and here, so I need 8 here, 8 here. Need an x here, x here. So x times 1 is x, that's this. Plus 1 times 8 is 8, that's this. And then all over, they both have the same denominator, so there's 8x. And then they look at this as being a fraction over a fraction. So they look at it as x plus 8 over 8x divided by something. By a fraction means multiplication of the reciprocal, like that. So I just took the bottom, flipped it, and brought it up next to here. And then these are identical. So all you're left with is 1 over 8x right here. Let x go to negative 8. You get negative 1/64. Lots of algebra. All right. X goes to negative 4. Negative 4 squared is 16. 16 plus 9 is 25. Square root of 25 is 5. 5 minus 5 is 0. So we get 0 on top. Negative 4 plus 4 is 0. So we do have 0 over 0. I see a square root. I'm thinking conjugate. You should be thinking the same. So here's my original square root up there. My conjugate is right here. I'm introducing it on the top and the bottom. Got my little plus sign there, right? Opposite of what I saw here. When I multiply here, I only have to look at the first ones and the last ones. The square root and square root together basically go away, and all you're left with is the x squared plus 9 that was under them. There. And then negative 5 times 5 is negative 25. And then go ahead and just drop the parentheses here. X squared plus 9 minus 25 is x squared minus 16. That's this. On the bottom, leave these alone, right? Just don't even touch those. Notice that the numerator, right? The numerator is a difference of squares, so that becomes x plus 4x minus 4. And how convenient is that? These two cancel. So here's what's left, right? And now let x go to negative 4. So you get negative 8 up here. And then when you plug in negative 4 here and do all that work, you should get a 5. Oh, I'm sorry, 10 down there total. And then you just reduce the fraction. So conjugate is a big deal. All right. Let's let h go to 0 here. If this is 0, this is just x. X cubed minus x cubed is 0. So I've got 0 on top. On the bottom, it's also 0. So what we'll do here, x plus h, is we'll expand it, right? So we multiply it times itself 3 times. We get this. We notice that the first term x cubed will cancel with that x cubed here. Everything that remains has an h in it. I factor an h out. I cancel the h's. Here's what remains. Let h go to 0. These two terms vanish, and you're left with 3x squared out front. All right, this one's a little tricky. All right, find the following limits. So let me work this through a little bit. All right, let g of x be this. So x squared plus x minus 30 over the absolute value of x minus 5. If I'm going to try and figure out what happens as x goes to 5 from the right and from the left, then I'm going to need to be thinking about a number line here. Here's my x values. Coming in from the left means I'd be picking values, trying to plug in close to 5, like 4.9. Coming in from the right, I'm plugging in values that are bigger than 5, so like 5.1. Now, let's just see what happens if I try and plug 5 in, right? If I plug 5 in here, I get 25 plus 5, that's 30. Take away 30, we get 0. 5 minus 5 is 0. Absolute value is 0, 0. So this is the form 0, 0. The problem is the algebra is a little different because we can factor the top, right? I should have done that just to show you. If I look at that and I factor the top like this, so that's g written again. You cannot cancel these two. And the reason you can't cancel them is because they're not the same. One of them is x minus 5. The other one is absolute value of x minus 5. But what we can do here is we can say, we can determine what this last piece is going to be. Oh, I need my pen. Okay, let's talk about this right here. Let's just try something. Let me start with numbers that are to the left. You know what? No. Let's start with this one over here. So let's start with numbers to the right. Okay. Let's just try 5.1. So let's say I plug 5.1 in here. What's g of 5.1? Well, we get 5.1 plus 6, and then we get 5.1 minus 5 is 0.1, and then over 5.1 minus 5 is 0.1, but absolute value. Well, the absolute value of 0.1 is 0.1. So these do cancel because they're the same sign. And therefore, I just get, what is that, 11.1. Now, let's get something even closer to 5. How about 5.01? G of 5.01, I get 5.01 plus 6. And then 5.01 minus 5 is 0.01. On the bottom, absolute value of 0.01. Again, these two cancel because they're both positive. So I get something like 11.01. And if I keep doing this, what's happening is it's getting closer and closer to 11. Now, what would happen if I come in and I do numbers on the other side? Okay, so this appears to be approaching 11, right? If I do something like 4.9, what's g of 4? I don't like that color. It's g of 4.9. So we get 4.9 plus 6, and then we have 4.9 minus 5 all over absolute value of 4.9 minus 5. Now, the top is going to be 10.9. But then I have 4.9 minus 5 is negative 0.1. The bottom is the absolute value of negative 0.1. And the absolute value of negative 0.1 is positive 0.1. So 10.9 times negative 0.1 over the absolute value is 0.1. Now these two are the same except they're opposite in sign. So these will cancel, but I'll have a negative pop out here. I can get rid of that one. So instead of being positive 11 over here, like we had over here, it's now negative 10.9. And if we try something even closer, like 4.99, then what's happening is that it's getting closer and closer to 11 because it'll be like this one right here will come out to be 10.99. But again, the two pieces that we get here and here will be opposite in sign, so we'll always get that negative to pop out. So the moral of the story is this. If we come in from the right, we're getting 11. If we come in from the left, we're getting negative 11. Therefore, since the limit does not exist from both sides, the answer is no. All right. Clear that out. Let's move down here and take a look at what the graph is. So we said from the right, it was 11. From the left, it was negative 11. So it's not this. From the right, it's not. Let me see here. And this was as we were approaching what value? 5? Or wait, yeah, we were approaching 5. So it looks like this one right here. That doesn't look like 11, but it is. It looks like it should be a little bit closer up here, but from the right, it's approaching 11. From the left, it's negative 11. And then at 5, it's undefined, so there's a hole there. So that is the answer. All right. Evaluate each of the following limits if they exist. All right. If the answer does not exist, hit DNE. Say DNE. All right. Shall we try and draw that? I don't even know if we should try to draw it. I think we can try and do it without drawing. Just do it purely algebraic. Okay. What's happening as x approaches 1 from the left side. That means I'm coming in like this. So I'm like 0.999, something like that. Well, which of these am I going to be on? Which of these functions on this piecewise function? Well, 0.99 is smaller than 1, so I'm going to use this one. So from the left side, it's spitting out x. So if it's 0.99, I'll draw the graph over here. If I'm approaching 1, from the left, it's approaching, let's see, it's going to 0.99. So it's looking like this. And the closer I get to 1. All right? Because if I do 0.99999, I'm still less than 1, and it'll be exactly what I plugged in. Now, at 1, let's see. Well, at 1 right here, I'm kind of jumping the gun here. Let's now try and come in from the right side. So this right here is approaching 1. Because we're coming in this way like that. From the right side, okay, I'm going to be looking at values that are like 1.01, something like that. That's bigger than 1. So that means I'm looking at this function. And if I plug in something that's a little bigger than 1 here, something really close to 1, I square it's going to be really close to 1 still. And then I subtract it from 2, I'm going to be really, really close to 1, right? It's going to be something like 2 minus 1. So that's giving me 1 also. So as I come in from the right, it's also coming in and trying to get close to 1. So that's 1. Now, if I do try and plug in 1 into the function, I'm going to be on this piece right here. And if I plug in 1, it says, don't worry about what you plug in. I mean, don't worry about the fact that it's 1. Just spit out 3. That means 1, 2, 3 here on my graph. 3, I have a solid dot like this. So that means that's 3. Okay, so that kind of takes care of the first 3. They're all kind of the same idea. Let's now clear this out and look at the next ones. We want to look at approaching 2 from the right, 2 from the left, and then, what's the limit at 2? So 2 from the right, 2 from the left, and then what's happening at 2. So here's my number line. I'm going to have some dogs barking here in just a second. 2 from the left, 1.99, something like that. We are looking at this right here. We take 1.999 and square it. It's really close to 4. 2 minus 4 is negative 2. So my graph, as I'm approaching 2, it's down here at negative 4. It's getting closer and closer to negative 4. That's down there. My answer's down there somewhere. Now, if I approach from the other side, like 2.01, now I'm on this one. And so I need to take a number that's a little bit bigger than 2 and subtract 1. I'm going to be really close to 1. That means I'm up here, and I'm coming in like this. And notice that at 2, just pointing this out, at 2, right, if I wanted to know what was g of 2, I would plug into this, and that would give me negative 2 exactly. So that means I can fill that hole in. So the limit from the left, right, is negative 4. The limit from the right is 1. So the limit from the left was -4. From the right was 1, and that means since they don't go to the same place, it does not exist. All right, so it says now to try and draw a graph. So you can kind of put the two ideas together here, and when you put the two ideas together, pick one of these. So I'll let you do that on your own. I got to do a quick pause. And this is a good place to pause. These problems are crazy. Okay, let's go ahead and pick up where we left off here. Find the limit, if it exists, of sine 3x over x as x goes to 0. So this is a very important problem. So what we need to be working with here is one of the kind of formulas that we had in class, or not in class, but that I've presented to you, and that's the limit as x goes to 0 of sine x over x equals 1. Or, better one, limit as anything goes to anything of sine of something over itself equals 1, only if whatever's in here and whatever's in here are the same, and they're both going to 0 when you take the limit. So, like in this problem, this x and this x are identical. X is going to 0, so they're both going to 0. When this happens, you get 1. All right, let's use that here. So here we have, when x goes 0, 3 times x does go to 0. And this does go to 0 also. The problem is they are not identical. So what we're going to do is we're going to be real tricky. And we are going to rewrite this. And we're going to say the one way to make them identical would be to have a 3x in the bottom instead of an x. So what I'm going to do is I'm going to introduce a 3 here. And I can't just throw a 3 in there. I have to throw a 3 on top also. So this 3 and this 3 would cancel. Also notice that you cannot factor a 3 out because this 3 is trapped inside the sign, so you can't just pull that out. So now these two terms here in the numerator and denominator, they fit this format over here. So when we take the limit of that, that's going to go to 1. And then times, this is a constant, 3. So the limit as x approaches 0 of just 3 is just 3 itself. So your answer here is 3. So we introduced that the most important part of the problem is that we introduced this 3 here and 3 here. Okay, next problem. For this one, again, as x goes to 0, I didn't mention this in the last problem, but when x goes to 0, the whole top, right, goes to 0. The whole bottom goes to 0. Because these, inside, each of these goes to 0. Sine of 0 is 0. That goes to 0. Sine of 0 is 0. So we know we have the form 0 over 0. But let's try now and do some algebra to make this thing work out. So I'm going to be clever here. I'm going to split this up as sine 5x over 1, and then times 1 over sine 7x. And what I'm going to do is I'm going to try and work with the part of this problem that's causing the issue. The part that's causing the issue is the fact that I have this, which gives me division by 0. So what I look at here is the argument, that's the thing that's inside, and I tell myself I'd really like to have a 7x up here. But I can't just throw 7x up there unless I throw 7x down here. Now, we know that this piece is going to go to 1 because of what I've shown you in lecture and things like that. The problem is now we have 7 times, let's see, the limit, that's going to go to 0, so that's going to be division by 0 here. However, this x, since this is all multiplication across the bottom, can be slid over here and placed right underneath here as an x. Get rid of that. And then let's put that x right there. Now this will go to 1 if we had a 5 out here. But I can't just have a 5 out there unless I put a 5 up top. So I put a 5 up there. So I've introduced all sorts of things. I introduced the 7x. I had to divide by 7x. I slid the x over. I needed a 5x. I introduced a 5. I had to put the 5 on top and bottom. Now let's just look at all of these things by themselves. If I take the limit of a constant, it stays a constant. This has the same thing here. They both go to 0. That's 1. This has the same thing here and here. This goes to 1 also. And this one right here, the x was gone, so it's just 1/7. So what you get here is 5/7. Very cool. Okay, for this one, let's see. If I let t go to 0, I get 9 times 0. Tangent of 0 is 0. Over sine of, let's see, 3 times 0 is 0. Sine of 0 is 0. So we have one of those forms we need to work with. So now I get to start trying to rewrite things here. Let me see if I can move this over here. All right. So this is limit t goes to 0. I'm going to split this tangent 9t and make it a sine 9t over cosine 9t, but instead of putting the cosine underneath it, I'm going to put it over here. And then I had a sine 3t out here on the bottom already. I'm going to just split that out way over here. Okay, let's see if you can follow this now. The issue that I'm having is this one right here gives me division by 0. So I'd really like to have a 3t up here. Can't do that unless I put a 3t down here. This one still gives me division by 0. So I'm going to take that t and I'm going to slide it all the way underneath this right here, make that a t. And now I'd really like to have a 9 here, so I put a 9, but I can't do that unless I add a 9 up here. Okay, so I have 1, 2, 3, 4, that t went away, 5 things here. Let's let t go to 0. We have 9 times, we know this one's going to go to 1. Now this one, cosine, let's see, 9 times 0 is 0. Cosine of 0 is 1, so that's just 1 over 1. This one we know is 1. This one right here is 1/3. So we get 9 over 3, which is 3. All right. Classic problem here. This one's really cool. Not really cool, but it's just kind of going to work out in a weird way. All right, so let's check this out. Let's let theta go to 0. Sine of 0 is 0, so I have 0 on top. Let's see, 4 times 0 is 0. Tangent of 0 is 0, so I have 0 on the bottom. So that's the form where we're going to need to do something. So here I go. Do something somewhat unorthodox here. I'm going to multiply the top by 1 over theta and the bottom by 1 over theta. And then I'm going to multiply here, and then here I have to distribute through. So what I get is this limit, theta goes to 0. The top, 1 over theta times sine, is sine theta over theta. And on the bottom, let's see, 1 over theta times 4 theta, the thetas cancel, I get 4, plus tangent theta over theta. So that's the same as tangent theta over theta, like that. Now you can probably already tell that when I break this limit up and I do the limit on top and bottom, this one right here is going to go to 1. So that's no longer a problem for me. And then on this one, I need to figure out what that does. So why don't I just take that over here real quick and just talk about what that is. That's actually a sine theta over cosine theta, but I'm going to write the cosine theta over here. And then I had a theta on the bottom, so I'm going to put it right there. And notice that that has the form that's going to turn into a 1, and then this one right here, cosine of 0 is 1, so we get 1 times 1. So I know that when I take this limit, which I'm going to do now, the top is going to be a 1. I'll put it down here. The top is a 1. Then I have the bottom left-hand corners doesn't change, and then I have the tangent theta over theta is going to turn into a 1, so we get 1/5. All right. Find the number a such that this limit exists. All right, so we got to try and figure out what a can be plugged in here so that we get this limit to exist. So what I think I'll do is I'll first just take a look at this and see if there's a way maybe I can try and factor it. So 3x squared plus ax plus a plus 6. Let's see, if we try and do grouping on this, the reason I'm trying to factor is because I know the bottom factors to be x plus 2x minus 1, right? Now, if I factor out here an x out of the first two terms, I get 3x plus a. And then over here, I cannot make this factor because I don't have anything to pull out, so I have plus a plus 6. So that is not working, right? So let's try something a little different. Grouping is usually what you use when you have 4 terms. So let's try a different approach. Let's say that we try like an AC method on this. Or, you know what, I think I'll approach it this way for you. This will probably work out a little bit better for you. In order for this to work, we need to take care of the problem with x being negative 2. And that means this factor needs to be able to cancel, which means up here we need x plus 2 to come out of this. So what I'm going to do is say I need to be able to divide 3x squared plus ax plus a plus 6. I need to be able to divide that by x plus 2 and get a remainder of 0. So I'm going to do long division here. Okay, so let's try and figure out what I multiply x by to get 3x squared. Well, I multiply by x. That gives me I multiply by 3x. That gives me 3x squared. And then over here, I get plus 6x. And now I come through and I subtract this. So this and this changes. These cancel. What I'm left with here is ax minus 6x. I can't put those together. Plus a plus 6. Now what I need to do is turn x into ax minus 6x. Notice that's the same as a minus 6x. So I need to multiply x by a minus 6. If I do that, let me write the rest of this down here. Let's just imagine that wasn't there. Then I multiply a minus 6 times x. I get a minus 6 times x. Then I multiply a minus 6 times 2, and I get plus 2a, and I get minus 12. Oh, that's not a 12. Then I come through here, and I subtract this. Subtract, minus, makes that a plus. And then these go away. Here I get negative a, and then these two together give me plus 18. And this is my remainder, and I need that remainder to be 0 for this to work. So that means that a must be 18. So if a is 18, this should work. So let me go back up here, and let's plug in a is 18. If we do that, I think I'll just erase this. If I rewrite the problem with a being 18, I get 3x squared plus 18x plus what's 18? 18 plus 6 is 24. All over, we already know this is x plus 2 times x minus 1. Now the top should factor. Let's see, I'm rewriting it now. And now, let's see, I can pull a 3 out of everything, right? If I pull a 3 out up here, it should be x squared plus 6x plus 8. And then that factors to be x plus 2 times x plus 4. And now these two cancel, and then you could take the limit. So a must be 18. And now if I did that, and I now let x go to negative 2, up here I get, I know this is real sloppy, but 3, let's see, negative 2 goes in here. Negative 2 plus 4 is 2. Then over, let's see, negative 2 minus 1 is negative 3. These two cancel. I have a negative, so negative 2. Interesting. Curious to see what the book did or what they do here online to get this solution. Let's have a look. Where'd it go? Is that it? Nope. There we go. I think they just tried some things, but I think what you can do is do it my way if you want, or try and figure out a different way. I hope it makes sense. It's a little bit of a complicated problem. It's not something I would normally put on a test, but it's a good exercise. I think that actually does it for 1.4. Very good.